This turtle's medical condition might have a funny name, but it's no joke. Charlotte the turtle suffers from a serious and increasingly common syndrome called butt. Since being hit by a boat years ago, Charlotte hasn't been able to swim normally. To help, experts in 3D printing and advanced computational design came together to develop an innovative solution that they hope can be scaled to help turtles around the world suffering from the same condition.
Butt is also known as positive buoyancy syndrome, and essentially, when turtles get hit by boats, their shells can deform slightly, and that deformity causes air to get trapped in the back of their shell. So instead of sitting neutrally buoyant like turtles do, they sit with their butts up in the ocean. That can cause some pressure on their organs, it can cause some damage to their GI tracts, and in general, that air in the tract doesn't allow them to function as a normal sea turtle.
Mystic Aquarium reached out to Adia, a 3D design and integration specialist, for help with their male green sea turtle, Charlotte. The veterinary team at Mystic tried several methods of counteracting Charlotte's buoyancy, but attaching weights directly to his shell caused irritation, and harnesses made of fabric or neoprene were easily torn or scraped off on the edge of his tank. Adia was contacted to see if 3D printing could be the answer.
The problem we have been trying to solve is essentially putting weights on the back of Charlotte, which sounds very simple, but it ended up being a very challenging process. The only way to really get something to stick to Charlotte was to build a custom device.
To help create a customized harness that would fit comfortably and snugly to Charlotte's unique geometry, Adia called in the computational design experts at New Balance. Together with 3D printing company Formlabs, they worked to develop a scan to 3D print workflow that they hope can be refined and replicated for all turtles suffering from butt syndrome.
Designing for 3D printing allows you to create these one-of-a-kind items in a way that traditionally tooling would not. Computational design comes into play where you obviously don't want to be designing one for one manually because it would take a very time-consuming process. So being able to create a workflow that allows for a custom-generated harness is really powerful.
Computational design creates a system for developing design iterations based on input data, like 3D scans of a turtle shell, and tests those iterations through advanced simulations. The Adia and New Balance team needed to find the right material. The harness had to be highly accurate to provide a perfect fit, and durable enough that bumps on the tank wouldn't affect its performance. Additionally, to scale the project worldwide, the workflow needed to be accessible and affordable for other aquariums to replicate.
We've looked at many different 3D printing processes for this project, and we landed on SLS for a few reasons. One is the build volume, size of components. Two is that we could build parts without supports. And three was we could find the proper materials that had the rigidity we needed for this project.
SLS, or selective laser sintering, uses a laser to fuse layers of powder into solid objects that are lightweight yet strong enough to handle complex designs. With material choices like carbon fiber nylon, SLS was an ideal choice for Adia and New Balance to use during testing.
Going into this project, we actually wanted to design the harness to fit in a fuse build volume solely for the purpose of accessibility. We want to have other aquariums and other facilities have access to SLS technologies. The fuse has one of the largest installation bases and would be most accessible.
Months of design, testing, and refining led to a breakthrough. When Charlotte tried the harness on for the first time, they realized they had found a viable solution.
This new version of the harness is so far seeming like a really good addition for him, and as we're getting him to wear it more and be more consistent, we'll be able to add the weights back in and just see how he tolerates it. But for now, it's a really positive sign that he's doing well with it right off the bat.
Once Charlotte becomes accustomed to the harness and regains strength in his rear flippers, the Mystic team will gradually start adding weights to counteract his positive buoyancy. With Charlotte as an early stage adopter of the technology, the team is now looking for help to refine and scale the workflow.
The ideal outcome of this project would be to make this technology accessible to other aquariums. So our hope is an aquarium could upload a scan of a turtle, have access to an online design tool, which would allow them to make a few design decisions and export a file, which would allow them to build a harness on a fuse and to, again, help to better the quality of life of their turtle.
Adia and New Balance are looking for experts in computational design and mechanical engineering to help scale this project. If you're interested in helping to develop a software tool that could assist turtles like Charlotte, please visit the link in the description below for more information.